All right, so when we do these solution stoichiometry problems, if you guys notice, the steps are pretty similar to what we did for regular stoichiometry. The first step is to balance. So let's get started with balancing this equation. So if we start the balancing, we want to count all the elements on the left side and the right side of the arrow for this equation. Okay, so what we're going to do is we're going to start off just by splitting the equation down the middle. Okay, so what we're going to do is we're going to start by looking at the left side and the right side. All right, so if you guys take a look at the left side of the arrow, you guys should see that we start off with AL, H, and CL. Okay, so that's going to be the elements. And then what we want to do is we want to count how many we have on the left side versus the right side. So I'll give you guys about a minute or so. See if you guys can count the elements on the left and the right side, and then we'll go over your counts. All right, guys, so hopefully you guys got the count for the elements. I'm just going to give them to you guys just to make it easy. On the left side, you have 1 AL, 1 H, and 1 CL. And on the right side, you have 1 AL, 2 H's, and 3 CLs. Okay. All right, so before we move on, let's talk about these new things that you guys see right here. These things in parentheses next to the compound. So these right here, we call them the state of matter notations. Okay, so state of matter. And basically what these things are telling you is whether that chemical is going to be either a solid, a liquid, a gas, or something called aqueous. Okay, and then obviously you can tell that they're symbolized by the letters in the front. So solids, if a chemical is a solid, there's a parentheses S next to it. If a chemical is a liquid, you'll see a L next to it. If a chemical is a gas, you're going to see a G next to it. And aqueous will be AQ. Now, aqueous is just a fancier way of saying dissolved in water. So this compound right here has AQ next to it. So that means that HCl is dissolved in water. So you have a solution, and then there's HCl dissolved inside of that solution. That's pretty much all it means. Okay. And these notations will be helpful when we do our labs, because that way you can identify very easily what chemical you are looking at. If something is a solid, right, if you see an S next to it, that's going to be your solid chemical. Okay, if you have a chemical dissolved in water, it's going to be the one that's AQ. All right, so that's pretty much what those are. They're not really relevant for the actual balancing or stoichiometry. This is just more for when we do labs, so you know what state of matter each compound is in. Okay. All right, so now we can do the balancing. So for the balancing, we want to add to the side that has fewer. So let's start with the H. So we need to add some H's to the right side of the arrow. So in order to do that, we got to add HCl. That's going to change our numbers to 2 and 2. Okay. All right, now we need to fix up the CLs. So we got to add HCl, but if we do that, you guys are going to notice that it's going to mess up your hydrogens as well. So your hydrogen is going to go to 3 and 3. Okay. All right, so far so good with the balancing? All right, now you're going to see that the issue here is that we have fewer hydrogens on the right side now. So what we're going to do is we're going to add hydrogen to the right side, H2, which gets us to 4. Okay, but again, same issue. We got to add hydrogen to the left side now, which is going to be HCl. Okay, so this is kind of a harder balancing question because you need to go back and forth in order to fix up the numbers, and that's going to give us 4 hydrogens and 4 chlorines. All right, so let's fix up the CLs now. We obviously need to add more chlorines to the right side, but in order to do that, we have to add the entire compound AlCl3. And if we do that, we're going to have 2 aluminums on the right side, and we're going to have 6 chlorines on the right side as well. So a lot of adding. Okay, but we are almost done. Looks like we need to fix up these chlorines right here. So we got to go from 4 to 6. So we're going to add 2 more HCl's. That's going to get us to 6 right here. 6 hydrogens. And then you guys can see if we add 2 more hydrogens to the right side, that gets us to 6. And then we add 1 more Al, and we are finally done. So that was kind of a mess to go through. But your final coefficients, the numbers that go in the front, will be 2, 6, 2, and 3. Okay. All right, so I know that we added quite a bit, but like I promised you guys, as long as you just keep adding to the side that has fewer, eventually it will balance out. Okay. All right, any questions with the balancing right here? All right, so that's step 1 of solution stoichiometry. You want to balance the equation. Now what we want to do is we want to figure out the starting chemicals and the ending chemicals, and we want to ignore the excess. So very similar to what we did in the regular stoichiometry problem. So let's take a look at the question, and I want you guys to see if you guys can identify what your starting chemical is. So just write it down. You don't need to find the molar mass this time. I just want you guys to write the name or the formula for the starting compound and the compound that you want to end with. So kind of reading comprehension here. So I'll give you guys about 30 seconds. See if you guys can read the question and just write down on your paper, what is your starting chemical and what chemical do you want to end with? It'll take about 30 seconds to see if you could identify those. All right, so if you read the question, it tells you, suppose you have 100 mils of a 0.5 molarity, and then the compound that your solution is HCl. And it's reacting with excess HL. Excess means you have so much of that compound, you don't need to worry about it. So we're going to ignore Al. So obviously, Al is not going to be important for this Stoich problem. Okay, and then the question is asking how many grams of AlCl will be produced. So there's 2 chemicals that we have. And so these are the 2 that are important, HCl and AlCl3. But the question is asking how many grams of AlCl3 will be produced. So you want to end the problem with AlCl3, which means obviously you're going to be starting with HCl. Okay, so that's step 2. Just need to read the question and figure out what your starting and your ending compounds are. So for step 3, we want to find the molarity to find the moles of the starting chemical. So this is very similar to what we did in our warm-up. So we're going to use the molarity equation. So capital M is moles over liters. And then step 3 tells us you want to find the moles of your starting chemical. So here we are going to find the moles of HCl. Okay. So we are using the numbers that we have to find the moles of your starting chemical. Okay. All right, so let's just plug in the values that we got. Capital M is 0.5 molarity. So we're just going to plug in 0.5 molarity equals moles divided by, and then we said 100 milliliters is 0.1 liters. Okay. This is pretty much the exact same thing that we did in our warm-up. All right, so after that, what we're going to do is we're just going to multiply both sides by the denominator or the number on the bottom. So 0.1 on both sides. That way this cancels out. And on the other side, you get 0.1 times 0.5. And for the end of step 3, we are going to get 0.05, and that will be moles of your starting chemical, which is HCl. So that's the end of step 3 right there. Okay, but the stoichiometry here is a little bit easier because you only need to do 2 fractions. So I want you guys to just set up on your paper 2 fractions that we're going to write on, and that's going to be our final answer. Okay. So for the stoichiometry for solutions, you only need to do 2 fractions, not 3. It's a little bit easier. All right, so let's set up this first fraction right here. You want to get rid of moles of HCl. So on the bottom right here, you're going to put moles of HCl. And what you want to do is you want to turn it into AlCl3. So we're going to put moles of AlCl3. So this fraction right here is pretty much the same thing as the second fraction in regular stoichiometry, where you turn moles into moles of the other chemical. All right, and so what that means is you're going to get the numbers for this fraction from the balanced equation. So again, this is the same thing as the second fraction in regular stoichiometry. Okay, so if we look at the balanced equation, AlCl3 has a 2 in the front, so we put a 2 on the top. HCl has a 6 in the front, so we put a 6 on the bottom. Okay, so that's the first fraction for solution stoich. All right, now for the last fraction, it's the last one, so it's pretty much the same thing as before. You're gonna get moles of AlCl3, and we are finally converting it into grams of AlCl3. So grams of AlCl3. And the numbers for this fraction are going to be similar to regular stoich. The last fraction is the molar mass. All right, and that's pretty much it. All you have to do is figure out the molar mass, plug it in, and solve for this equation. Okay, so I'm going to give you guys about 2 minutes. See if you guys can find the molar mass of AlCl3, plug it into this fraction, and see if you guys can solve out the entire equation right here. So I'll give you guys 2 minutes, and then we'll go over it together to check our answers. Okay, so you got to find the molar mass of AlCl3. Hopefully you guys saw that Cl is 35.45. There's 3 of them. And then there's Al, which is 26.98. And so you should get a molar mass of 133.33. And so you're going to put that next to grams on the top. And then on the bottom will be 1 mole. Okay. So that's the molar mass of AlCl3. All right, so all we got to do now is plug it into the calculator and we're all done. So we're going to take our starting number, 0.05, multiply everything on the top, divide the bottom. So we're going to multiply by 2, divide by 6, and then multiply by 133.33. And you should get a final answer of about 2.22. So your final answer will be 2.22 grams of AlCl3. All right, and that's pretty much it for solution stoichiometry. So let's talk about what this means real quick, and then I'll let you guys start on your problem. But basically what this is telling us, and this is what we'll be doing in the lab at the beginning of next week, is that if you have a solution, right? Okay, so you got a solution, it's 100 milliliters, and it is 0.5 molarity HCl. So you have this chemical HCl. And then if you put excess aluminum, so let's say we get some aluminum metal, and then we put a bunch of aluminum inside of it. Okay. The 2 chemicals are going to interact with one another, and they are going to end up making inside of this solution. This solution is going to create 2.22 grams of AlCl3. Okay, that's pretty much what it's telling us. You got this solution of HCl, you put aluminum inside of it, and it's going to turn into a different compound, specifically 2.22 grams of AlCl3.